Hey everyone, this is Jay from Interview Query, and today I am recording a video on the take-home exercise that is in our take-home challenge book for premium members. I figured this is a good way to try to solve a problem in real time and effectively go through about how I would personally solve it, and really just demonstrate, you know, how we go through these take-home challenges. This one is specifically more focused on SQL, so it's not as bad. Yeah, filming this on March 17th. Got a beer in my hand. It's coronavirus time, so tough days, tough days. So let's look ahead at this problem set right here. Make this a little smaller. Cool. So this one is from Goodwater Capital. So Goodwater is a venture capital firm, actually. And I actually remember them from the time that they were actually about to invest in one of the startups that I was working at a few years ago. They have an interesting position open for a data scientist, the reason why you think a venture capital firm would hire data scientists is because they actually are doing something pretty interesting in that they want to go through data and figure out how to predict the value of a company given all the data on all the startups, in tech and all of Silicon Valley and the greater world, right? And so, it's kind of changing the game for venture capitalists, depending on how successful they get. But this one is more of an analytics question. And so if you open up the Goodwater tab, the data science challenge, we can go through and look at this requirements doc, right? And so essentially the question posed is that there are two tables, right? There's one table for product, and then there's one table for downloads. So essentially each product has either an iOS app or an Android app, and then we have a downloads table that also has basically the number of downloads for every single day for each app, right? And the question is asking, write a SQL query that calculates the year-over-year growth of the trailing 28-day average of product level downloads for each product in each day. Okay, so there's a lot there. It's actually pretty complicated, reading that first sentence doesn't really make too much sense, but they break it down, right? Trailing n-day average as of day D is the average of the metrics value over D minus n plus 1 day. So basically, we can think of this as like a moving average, right? So the past 28 days, average that value, and then that will be the value for that current day. So if we're looking at something like, let's say January 31st, then the trailing 28-day average would be from the average number of downloads from January 3rd to January 31st. And then year-over-year growth would then be the value of the metrics value divided by the metrics value a year ago. So basically, that trailing value from January 31st, 2020 divided by January 31st, 2019. And then product level downloads is the total number of downloads on that day if they exist for the other values. Cool. Okay, so let's set this up. In the take home, you'll see like a setup.sql. Basically run that to create the sample data that we created for this assignment, and then also the actual tables as well. And so I'm using MySQL Workbench. You can get it set up pretty easily. I think we'll put like a walkthrough for how to set it up, but it's right here. And we also have a SQL server that exists right here. So basically you'll have to set up MySQL, get it running, initialize the database, and then run the SQL to actually create the tables and insert the data that we have. So that's pretty easy. We're gonna pass by that. Actually, it was a little bit of a headache for me, not gonna lie. But if you have any questions, we'll try to figure them out too. I haven't posted this anywhere yet, so obviously I have no idea what the questions would be. All right, cool. So let's start out with the question. So I've already done it. So if we run something like this, select all from products. You have to use this. This is the results grid. So these are our products. Sample fake data here. And then we can run another one to look at downloads. Gotcha. And so here you have the app ID, date, downloads. Okay. All right. So first off is we need to get first, before everything else, we need to get the number of downloads each day for each product total, right? And so the way we can do that is first by doing a join, right? And so if I grab this from products, P, inner join downloads as D on P dot app ID is equal to D dot app ID. Correct? And this should get me everything that I want initially. So let's run that. Okay, I need a semicolon. P dot, oh, I don't have the product ID. Oh, okay, so if I look back at here, this is actually going to be iOS app ID, right? So given the fact that the products table has two columns, an iOS app ID and an Android app ID. Okay, cool. So this doesn't help us too much because what we need is also the Android app ID if it exists, right? And so this only gives us the iOS downloads. So you can effectively write another query and we can union it together with this one to get both of the actual downloads for both apps. Dot Android app ID equals D dot app ID. So why do we have to union this? Because if we join it, then all we're gonna get is if we join these two first, this one, and then we added this, let's say right here, this wouldn't work, right? Given that, given the fact that this would actually give us not what we wanted, given the fact that if we join on this app ID first and then we do another join on the Android app ID, then we would duplicate the amount of apps, right? So if you look at this result table, we'll see that effectively, I wonder if I can make this bigger. Nope, okay. We can see effectively that the number of products is consistent on a per day basis with per downloads, right? If we join that to Android after that, then basically we'd be joining this on top and we'd be getting like a multitude explosion effect where for every single day, for every iOS app, for every Android app, we'd get duplicate numbers in terms of the total downloads. We don't want to do that, right? Because at the end of the day, we want the total downloads number to be the correct number of downloads for both. So that's why if we union both of the tables, that allows us to basically get only two additional, all of the Android downloads and all the iOS downloads in separate buckets. So once we do this as well, and I'm going to do not a select all, but we probably just need the P product ID. We need the date, and then we need the downloads. Looking to my right on my other screen, where I've done some of this work already. Okay, cool. So then we can create a table. So MySQL is kind of dumb. They don't let you do nested. They don't do CTEs. So instead, we're just going to create temporary tables. Yeah, I'm really figuring out the limitations of MySQL in the past few days when going through this exercise beforehand. It's not great. We've really done a better job with the later SQL versions, but fortunately for us, we don't have that. We don't have that option for some reason. So creating this. Okay. So actually, we don't want to create this as a table, right? Because this is the total number of downloads. So now we actually want to do another from statement here and grab the total number of downloads not separated by app. Okay. That's weird. I turn off Slack. That wasn't great. So we have the product ID, date, downloads. And then this is going to be a sum to get the total number of downloads. So let's just run this query first, see what the output is. It complains. It needs a semicolon. So picky. Still doesn't work again. You have an error in your SQL statement. What did I do wrong? By 1, 2, select. Oh, missing that right there. Cool. Downloads does not exist. Download does not exist. Downloads. Alright, cool. So now if we look at this result table, result grid, we can see that this generally looks right. We have, for every product, we have a singular date, and then we also have the total number of downloads. Cool. Great. Kevin.
What?
I'm recording. Alright, cool. So let's create a temporary table. Cool. So now going to create this table, run it. Let's see. Create it right there. You see 9,372. That sounds right because the data set is like 6 years. It's 365 days plus 4 products. Someone else can do that math. Cool. So now that we have effectively this table, we can look at it. And okay, so now what we want to do is we want to get this trailing average, right? So first we got the total number of downloads for Android and iOS together, and now we want to look at trailing averages, right? So to get trailing averages, there's one pretty effective way of doing it, and because we're in MySQL, we're actually a little bit limited, but effectively what we have to do is, we have to make a essentially a way that we can cross join the table to itself, right? So it's actually self join. But what we want to do is that we want to make it so that for every single date field, for like 2013 01 01, we want the last 28 days behind it, right? And all those downloads. And then if we run an average function and group by this date field, we'll get the average value. But it won't be for this table, it'll be for the other table. And so the way I'm going to illustrate that is I'm actually going to first look at what the table would look like if we just did this join on its own. So the way we're going to do that is we're going to grab daily downloads as dd1 inner join. Oh, and it doesn't let you reference tables twice, so we actually have to create a second temporary table now called dd2 select all from daily downloads, and then it lets us then insert the value that way. Cool. So on dd1 dot, so we're going to join on the product ID, right? So these have to be equivalent, but each product has to equal the other product. And then we're going to join on this trailing average. And the way we do that is we're going to look at the date difference between the first date that we care about and then the second date value that we care about. If it's less than or equal to 28, then we're good, right? So that's the trailing 28 days. And the way I'm going to illustrate this to you guys is we're just going to look at all of these values and then look at all of these values and then see if we can understand what's going on. Got the semicolon. Cool. Awesome. So we see essentially for product one, this is a pretty good picture, right? So this is the first value. Am I right? And this is the second value. So for date this, for date that, 26. Okay, so this isn't a great picture. So why don't we actually narrow it down to 1 day on DD1, so that we actually, because we started out with 2013, so that's why we don't see a number of values behind it. Okay, cool. So we've isolated DD1 dot date. Wait, no, it didn't work. Okay, sorry. On this. Didn't work again. My bad. Error, unknown column d1.dt. Oh, we did not call it dt. Oh, we called it date. Oops. Hopefully that doesn't give us an error. Okay, cool. So we see that, here we go. So this is product one, right? Total downloads on this date. This is 28 days before, right? Okay, and we look at the next one. So product one, still the same date. So if we order by this way, this number is going to be the same, right? Because this is the total download. This date is the same, but this is going to be every single date beforehand plus all their corresponding downloads. So now all we actually have to do is if we do a group by clause, and so we do, basically we have to specify one product ID, and then we'll do one dot date, and then average this dd2 dot total downloads, because this is the value that we're actually having to average in this column. We'll see that it, oh, okay. So look at this. This is actually giving us an error. Like we see that this is 2, 2, 2, 1, and it keeps on going for some reason. And that's because we actually didn't specify our lower bound for our date difference. So while we said we had to be within 28 days, you know, this is SQL. They don't understand that negatives are also involved. So we also have to make sure that it's greater than or equal to 0. So now it's actually between 0 and 28 days before. So that was a good catch. That's why we do this. That's why we do these kinds of debugging things beforehand. Aggregate without a group by. Yes, yes, I need a group by. Okay. Cool. We got our values. So I'm going to call this as trailing downloads. And then remove this where. And so if I run this, then, oh, it takes some time. That makes sense. It's a lot of joining. Cool. So now we have our trailing downloads. See, we had this all the way, you know, for a while. And if we order it, you know, we can see that it continues to keep on going, you know, by date as well. Okay, so awesome. So now we can actually create this into its own temporary table because we have to reference it again. Very annoying, I know. Trailing downloads. Table trailing downloads as put this thing right here. Now I have to run this query. Should increase the size. Sorry about all this. DD2 already. Oh, I wasn't trying to run that. Okay. Next support. Data truncated. Warning. That's weird. Why not? It says 9,372 rows affected, so let's just look at what happened. It's probably not a good idea to name this thing as the same column. Actually, that's probably what it's annoyed at. Okay. So now finally we have to do the year over year. Okay, so we've gone this far. And now we have to look at how we calculate the year over year metric. So effectively, this is going to be pretty similar to the join that we did in the previous one, right? Because now what we have to do is look at every single value that is from 1 year ago from the actual date, right? So if we go through here and we take, let's say, trailing downloads, right? This TD. Oh, and we're gonna have to create another temporary table. Temporary table. Call it TD2. Select all from trailing downloads. Cool. TD1, inner join, trailing downloads, 2 on TD1.product ID is equal to TD2.product ID. So we always have to match product IDs, right? And then we have to do this where we grab the date and we set it equal to the date 1 year ago. And so this would be date sub in MySQL. And we have to take TD1. But we want this to match up to TD2, right? And so if we look at this, that means that we have to effectively match up where TD2 is equal to 1 date a year ago. So how would we go about doing that, right? So I don't think it actually needs to be an inner join in this case, correct? Because many of the times we're going to get, for all those values in 2013, we won't get a value that will actually match it. So here, if we do a join, and we do a join on date subtracted, let's say, we want TD2 equal to the date of TD1 dot date interval 1 year, right? So we want the second table to be equivalent to the first table minus 1 year. Let's just run it and see what comes up. How about that, huh? That is what makes this so great, because we can actually test it. And we can actually set a value. So let's say 2015-01-01. Okay. Sorry, what the date is equal to. And so let's run this. Can't reopen table TD1. Can't reopen table? What? What does that mean? Can't reopen table. Is it because I can't reference the name twice? I mean, I didn't. Oh, gotcha. So it's this one right here. So we actually created a temporary table called TD2, and I just try to reference it again. One. Okay, so let's see if this worked. Yep, 2014, and that's the value. Great, cool. I believe this worked. Yes, awesome. So now what we have to do is, I believe this said year over year growth, right? So that means that if we want the year-over-year growth, we have to calculate the value by creating. So this is our current date, or this is the current product. This is our current date, because we're using TD1 as a reference, and then we'll be taking the trailing downloads divided by TD1.trailing downloads as growth. So now if we run this, what is that value? That's gonna be, yep, this looks right. Awesome. So now we can effectively do this for all of them. We don't need to run a group by, given the fact that each value must have a trailing value for the most part. And yep, now we see it. Year-over-year growth doesn't change by much. I mean, we created random numbers, so don't hold your breath. But where's product 2? That's weird. Oh well, it's in here somewhere. There are 10,000 rows, so I guess it can't show everything. But yeah, I think we got that right. So awesome. Figure that out. Didn't take too much time. If you have any other questions, please let me know. Definitely try it in the MySQL sandbox. It definitely helps with understanding how different data frames get joined together, especially when you can play around with it and also look at what happens when you don't do these group bys and you just do these joins, right? And so, yep, that's it for now. Thanks for watching.